video here, part 2, number 18 through 21. You're still choosing your favorite method. And just like the first video, if you didn't watch that one, the only methods you can use here are factoring, quadratic formula, and complete the square. You cannot use solve by graphing as the solving method. You can use it only to check your work, but you must show all of your work. All right, number 18 here. Let's see. I'm going to, this is kind of a tricky one. Let's see, I do have a GCF, so let's see if I can factor. Because the reason I would normally jump right to complete this square, but if I divide by 5, I do get x squared with a 1, but then minus 7x plus 12, and I don't really want to do complete the square with that odd number in the middle. But I do know they're all divisible by 5, so maybe I pull out that GCF and see what happens if I can factor or not. So can I find two numbers that multiply to 12 and add to negative 7? I think I can, so I'm going to factor here. Okay. Let's see. Two numbers that multiply to 12 and add to negative 7 would be negative 3 and negative 4. And then that's really simple once you recognize that. So I'm going to set only the factors that have an x equal to 0. So don't include the 5. So we just set x minus 3 equal to 0. And x minus 4 equal to 0. And when I solve those, I get positive 3 and positive 4. Those are my solutions. Now, since I got rational solutions, I could have used complete the square or quadratic formula as well. But that's probably the fastest one, is to factor here. Number 19. All right, well, let's see. I'm going to move the 25 back over to the left, just so that everything's set equal to 0. So I have 3x squared minus 18x minus 27, that into a 5, there we go, equals 0. So what factoring method? Well, I can always use quadratic formula. Let's see about complete the square. If I divided by 3 here, I would have x squared minus 6x minus 9, which tells me I can use complete the square because this middle term is even, and that's what I want for complete the square. So here, I'm going to add the 9 to the right. Complete it by filling in my box. Now, why did I use complete the square instead of quadratic formula? Well, you can use quadratic formula, but then you have to use really big numbers, 18 and 27, and that's a little bit more work of simplifying. So if you can use something like factoring or complete the square, it just saves you a little bit of math and calculator error with all that stuff. All right, I take half of b and square it. So that's negative 3 squared, which is 9. The right-hand side becomes 18. The left-hand side, I have two factors that are the same, and you always fill in the x after the x with half of that middle term. So I'm going to square root both sides. X minus 3 equals. In front of the square root, I always put a plus or minus. And I'm going to simplify that square root. You should be able to recognize that the square root of 18 breaks down to the square root of 9 and the square root of 2, which is 3 radical 2. So I'm going to replace that square root of 18 with plus or minus 3 radical 2. And then all I have to do is add the 3. And it's going to squeeze right in front of that plus or minus. And that would be my final answer. And again, I could not have factored this because there's a radical, it's irrational, but I could have used quadratic formula if I did not recognize to use complete the square. All right, last couple. Number 20. All right, just like the last problem, I'm going to move the 8 back over to the left, so I'm in standard form. And first thing I always want to do is see if I can factor. Okay, that's just going to be the fastest. I need two numbers that multiply to negative 24 and add to 5. It looks like 8 and negative 3. So this actually does factor. Now, if you did not recognize that you could factor here, I would have used the quadratic formula because 5 and 8 are not divisible by 3, so I don't want to use complete the square. So to split the middle here, I'd have 3x squared plus 8x minus 3x minus 8 group my two terms, or find my two groups. The first GCF is just an x. The second GCF, I have a negative in front, and the only number I can pull out is a -1. But that's okay because I still get the same factor as the other set of parentheses. So my factored form is x minus 1, 3x plus 8, and then set those both equal to 0. All right, so the left factor becomes just +1, and the second one, I would have to subtract 8 first, and then divide by 3. And those are my answers. All right, that's why factoring works, because I got two rational answers. If you had done quadratic formula and gotten those same two answers, you just know that you could have factored and probably saved a little time. Last problem. First thing I'm going to do again is make this into standard form. Subtract 2x from both sides and add 4. So then you'll have 2x squared minus 8x plus 5. Now what I'm going to do here, if I don't want to use completely the square. I mean, you could. The middle term is going to be even, but I'd have 5 over 2. I'd have a fraction. We don't really like those fractions. So I'm going to say this is the time where quadratic formula might be your safest bet. We have terms A, B, and C. So I take the opposite of B, which is 8, plus or minus. So I put my 8, which is negative in parentheses, minus 4AC over 2A. Now you're going to need your calculator to simplify the discriminant, the value under the radical. So I'll put my -8 squared minus 4 times 2 times 5. And I get square root of 24. All right, now before you move on, the square root of 24 does break down. And you want to rewrite the square root of 24 like this. The square root of 4 times the square root of 6, which is 2 radical 6. So I'm going to replace this guy right here with that value. So it's 8 plus or minus 2 square root of 6 over 4. Now, I talked about this a little earlier in, I think, the last video. Don't just simplify the 8 over 4 and put a 2. That's not how this works. You cannot simplify that fraction until you simplify the square root. Now I can look and say, oh, 8, 2, and 4 are all multiples of 2, so I can divide those all by 2, which will give me 4 plus or minus the square root of 6. The inside doesn't change, over 2. And that would be your final irrational answer. Great. If you use another method and you want to check your work, ask your teacher for some.